Good morning, folks. Welcome to the Eagle webinar series. We're just going to hold off a little bit until we get some other attendees here. We're just seeing people coming through just now. Numbers are bumping up. Hope everyone's having a good morning. Today's topic that we'll be covering is ArcGIS and climate change. Two very important topics, and we're really excited to share some of the recent developments in this space, as well as some tips and tricks and some of the technology behind the scenes. So we'll just hold on a minute or so while we watch folks arrive. Okay. So good morning again, everyone. Welcome to the webinar. As I said before, we're talking about ArcGIS and climate change this morning. And we're very happy to do this webinar this morning jointly with our friends at ClimSystems, who you'll be hearing from very shortly. So in terms of our team today, I'll be kicking things off from a GIS perspective. We'll also be working with my colleague, Carol Tarragon, one of the solution engineers based in Auckland. He'll be giving us some demonstrations later on. But we're also very happy today to have a special guest in the form of Peter Urich. So Peter is the managing director of ClimSystems, which is an organization, a global leading organization, working on climate change analysis and prediction with a really strong geographic aspect to that. And this world leader happened to be based in Hamilton, New Zealand, so we're particularly lucky to have them in the local region. Peter himself has been doing this work for over 20 years. He's got a PhD in human geography, and he's undertaken a whole bunch of really interesting projects, some of which he'll be sharing with us later on this morning, including doing international event risk assessments, things like the FIFA World Cup. It was a pretty exciting application of climate change analysis. So that's our team for this morning. And we also have some guests from ClimSystems joining us in the subject matter expert space for Q&A later on. So the topics we wanted to cover today were just a bit of background in terms of the concepts we're talking about here, introduce ClimSystems and as an organization, and then have them give us a climate change overview for those of us who are not familiar with the concepts perhaps or are not deeply involved in it, an overview for what that means, including some examples from around their region, from New Zealand and the wider region. Then we're going to pass on to Carol to give us some practical demonstrations with some of the tools that many of you are using right now to do your work, and how that climate change information can be incorporated in workflows, and give you some tips and some tools you can use straight away. We'll then move to the end for a live Q&A session. So get your questions ready. In terms of the Q&A, you should see something on the side of your screen that looks like this, where you can use the Start Discussion button to ask questions. So we'll do our best to answer the questions at the end of the session, type them in, and we'll get around to answering all the questions at the end, either verbally or some of them we can answer online. So please do, as we go through, ask questions using that button that you should see on the side of your screen. So a little bit of context for the subject we've got today. As you know, our world is evolving rapidly in many different ways. That's human innovation in the areas of agriculture. We're urbanizing, we're looking at energy use and also consumption. Education is changing rapidly. Almost every aspect of our world is changing rapidly due largely to human innovation. But this progress does come at significant cost. There's a downside to this progress that we're making. That comes in the form of many different aspects which are impacting our lives increasingly, whether that's human-induced climate change directly, the carbon emissions and pollution that arise from that, extreme heat, wildfires, severe weather, all of these downstream effects that we're seeing because of this climate change-induced changes in our world. And this is leading to increased uncertainty and potential unsustainability. And we'll hear more about the details of this from Peter shortly. The context of this from Eagle's perspective is that we're geographers and that the technology we work with, Esri's ArcGIS, is essentially a tool for helping us answer questions that are related to the where, bringing the where and science together to answer key questions. We understand that the connections between these different aspects, whether it's climate change data or the things that you care about, that's a really key aspect, how we can combine those through geography. And GIS is essentially the tool that we can use to do that. We talk about the geographic approach being a means of collecting data, mapping and analysing it, using it to understand how the future will look, make decisions and then act. And this is used for almost any discipline where GIS is applied, but it's particularly relevant when we're looking at climate change data in relation to our own activities, infrastructure and people. The way we look at data, as we know, is through these concept of layers. The layers you bring into any map or any GIS reflect the questions and the projects you want to work on. So in the case of a climate change example, we'd be looking at some of the data sets that Peter will be sharing shortly, alongside maybe our assets, looking at agricultural data, looking at the landscape and terrain and how that interacts with it, looking at critical infrastructure, and helping to answer the questions about how these different layers interact. In terms of those layers, I want to pass across to Peter now, who can talk a little bit about this organisation, the work they're doing with climate change prediction data. Peter.
Yeah, Scott, thanks for having us here today. A great partnership with Eagle. It goes back about 15 years now, I think, maybe a bit longer. We're serious Esri users and have been, as I say, for at least 15 years. And just to reiterate the importance of the geographical approach here, especially with climate information, really very important that we can spatially articulate what is going on historically with climate for locales and also the future. We find the uptake of information is much better when it's not an Excel spreadsheet. Those are good for some things, but putting a map in front of people as a geographer, I really have based my career around actually displaying important information to people that they can take up and use. And as I say, we've been here since 2003 here in Hamilton, part of the University of Waikato initially at the Global Change Institute, but we developed SimClim and we had a ClimPax program in New Zealand, and we then developed a private sector company called ClimSystems. And we've been going since 2003. We still have IGCI, sits as a not-for-profit that we still work in as well. It's no longer at the university, but it's still active here in New Zealand and globally. So we have a lot of PhDs around, I think 13 now, maybe 14, who have been working in this area of climatology and GIS and earth systems, and we have meteorologists. We have a real wide range of people working here at ClimSystems. It's a multidisciplinary approach to climate that's required. So we can cover off lots of different things. We like being in New Zealand. We like to call us, and we see tomorrow first here, very innovative. We work globally. We have a global profile out of Hamilton. And it's really an excellent place to do this sort of work. And it's got a really good internet. So thank God for fiber, because we have a lot of data and we need a lot of data. And we're very focused on innovation. We really have that Kiwi attitude about problem solving and innovation. And we've been doing a lot of innovation and R&D over those 20 plus years that we've been in the private sector. We were doing that well at the university as well. And we've worked on thousands of projects, including with FIFA, and we have a very strong data culture. We're very fussy about our data, and it's very important, as you'll see. Next slide, Scott. I'll give you a very brief overview of climate change, because I think everybody that's here is probably, we don't have to convince you. Actually, the days of convincing people that climate change is real seem to have passed. We used to spend, a decade ago, a bit more time just convincing people that this was important. Now people are coming to us saying, we face it, we see it, it is a hothouse Earth that we're heading towards, we're reaching thresholds in our activities already, it's an important issue. We don't have to convince people anymore who come to us after information to understand the future and where climate change is potentially going. There's some big decisions we need to make here as global society. We seem to be a little slow on getting there. So preparing for climate change, risk, adaptation, and building resilience is coming in to a lot more areas that a lot more clients that we work with, whether it's government, whether it's private industry, whether it's non-governmental organizations, development banks, whatever it might be, they're all recognizing this and increasingly acting on this. But still, it's a slow process. It's taken 20 years for people to really get on board with this, but it's happening much quicker now. Scott, next one. So we do have a predicament here where we do need to get prepared. And over 20 years, we've been working with the IPCC and the data that's generated by the global institutions, creating the climate patterns that we ultimately work with and make accessible to end users around the world. That's really our goal and role here at ClimSystems, is take that very complex, huge data sets and work with that on site here. We hold terabytes of data. That's why I mentioned the importance of fiber and the internet. But we have evolved over time. We do a lot of R&D, bringing in now machine learning, data design engineering. We do a lot of validation, algorithm development. We have programmers, not just data scientists. We bring a whole team together and bring all kinds of different data into the picture, from land data, soil vegetation, covering agriculture, geophysical hazards. We have ocean data as well. We keep up. We're in CMAP 6 now. We have staff members on CMAP 7 committees at the moment, already looking over the horizon. You know, New Zealand first sees the light. We're already working on CMAP 7 areas. We bring climate and weather data in. And I'll mention right now that we do have a partnership with the New Zealand Met Service. So we have access to excellent historical time series data to build really high quality baselines in New Zealand. And then we work with Met Services around the world. Data quality is important to us. That's what we do. That's our daily work. We use the best available global data. We're always looking for that, sourcing it. It's a high priority for us, is to have that historical, high quality data that we can bring in, validate, clean it. No data is perfect. We work on cleaning, pre-processing, downscaling. We develop algorithms, test and visualize before we put anything out through what we do. Next slide, Scott. And data governance is really important too. This is where we interface with all our clients. We have that capacity to be both a data provider. You know, sophistication of the capacity out there is uneven. We work with all range of clients there. More clients are doing disclosures and they have to publications decisions. We help with that, assures more and more data and outputs are audited. They have to be prepared for that. Hence our transparency in our methods and data applied is fundamental so they can pass audits. Auditors need to know where the numbers have come from. Reputational risk for companies, you need tools and procedures, and increasingly be prepared for legal challenges when using future climate information. We like to be ready and prepared to defend whatever happens with our data. It's a very much an important approach. So over the years, we built up our capacity and a conceptual overview of our solution with Esri. So we work with Esri globally, certainly with Eagle here, with the team in Australia, We've been to Redlands and been to the UC in San Diego and the recent partners meeting in Palm Springs. We work very closely with Esri in getting our data into their systems. Not a simple thing all the time, but now we've worked through over the years, and Esri has improved too, of the ability to bring our extensive climate data into their ecosystem and use their mapping technologies and dashboards to do some pretty innovative work. And we really enjoy this relationship with Esri and their platform, working very closely through Dak Benjamin and such, and the whole Esri team. It's been fantastic at working with our sometimes complex data to make it accessible in new and exciting ways, especially with dashboards, as you'll see with Carol at the end of this presentation. So we have that relationship with Esri from Redlands all the way through to the local groups like Eagle and Scott and Graham and the team in Wellington. Next slide. I'm going to show you some examples of how we have pulled our data. We're Esri users, of course, here as well, quite powerful users of the Esri technology. I'm going to flick through some it's going to go pretty quick here. I'm going to show you a whole bunch of examples of outputs and through a few sectors to give you an idea of the range of things you can do with our data in different geographies, different problem solving and solutions. Here's an example that we're working on right now in Indonesia with the national power supplier. It's nationalized within Indonesia. We're doing a nationwide assessment of their energy infrastructure. And here's just one example from Jakarta of the power buildings, that they call them, and then the flooding instances there, extreme precipitation. In this case, we do flood models as well, which I'll come to later. Just one example from Indonesia, again, using the GIS program. Here's one from Nepal we're working on now for run-of-river hydro scheme. Again, they need catchment level rainfall information. We have access to certain historical rainfall data. We can map that. Scott, the next one, that's a baseline. And then future potential extreme rainfall for that catchment. So we can use all this sort of data where you can, this is spatially provided here, but you can extract that data and out into Excel and so on. But we have all those future patterns. Next one. And here's locally. Here, this is work we've done with Counties Energy, looking again at extreme water levels and inundation, and these are all their transformer areas. And then if you put the next slide up, it's very subtle, but there are changes there. If you zoom in, you can see there are more transformers potentially at risk from inundation. And the legend would express that, the difference between the baseline and then future. And this can be very helpful for operational decisions about what you need to protect. Next one. We did the same thing for extreme wind for counties. Again, as you know, in energy infrastructure, as we hear often, mainly in Auckland and Vector, when there's an extreme windstorm, trees come down, all that sort of issue is a big thing to know about. And you see the legend there on the right, extreme winds baseline up to 196 kilometers per hour. Next slide. See that it's gone up to 2,207 as an extreme. The extreme winds would become more extreme over time. This is very important from a planning perspective. And we work with the Met Service here on having I think it's a 50-year hindcast of gusts in New Zealand now that form the baseline, and some really interesting extreme wind analysis that we can bring into the GIS platform. Next slide. And we get very granular too. Here's an example of, and I can't tell you where that is, but there is our flood data we can do 1 meter resolution, but this is for a transformer site, and they want to protect that from flooding. So we actually converted what we were doing in ArcGIS and our scenario modeling and TIFF files and such into the CAD platform using ArcGIS tools. And then this can go right into the design of the actual resilience program which in this case was going to be the building of walls around this transformer station. So this was actually bringing our data down into the operational level, which is really quite important when you're looking at flooding and transformers and such across the Motu. Next slide. The other one is retailers. This is a very interesting area, growing in importance. Retailers are interested in many things, not only where their retail sites are, but whether people can get to them, and the risk of extreme events, in particular, disrupting their business. So we do value at risk and disruption to service work, also with our climate data, and we can bring that into the Esri environment, and then we can do some modeling there so they can run this as an enterprise license with Eagle or with Esri, and actually do continual monitoring and change of new sites that they have. They do supply chain analysis, even commodity analysis, which I'll show you in a moment, to see where their supplies of certain crops or livestock products are going to be coming from to feed into a retail environment, say it's food or whatever it might be. But the retailers are very interested in supply chains these days. COVID taught us that. Supply chains are important. They can get severed by extreme events, and it causes economic impact on retailers, sometimes quite profound. And they are very interested in knowing the future risk of these sorts of things. We're now doing cyclone, typhoon, hurricane modeling for the entire globe about future frequency and magnitude of such events. This has taken us months and months to prepare, but it's really robust and interesting data on such an acute and impactful event. Retailers are very interested in that sort of thing, as an example. Next slide. Yeah, so heat wave days can also be very important in terms of retailers' profile and what is happening and the risk that poses to their clients or their customers, you know, and the whole shopping experience. And we score this data for them so they can see which areas are potentially more problematic and can be prepared for that, even from an energy auditing or energy preparation in terms of their facilities, to know that there's going to be change and how might that change impact on their experience of their customers. Next slide, and you'll see that's 2005 baseline. And there we go with the scores going up to 2050 using a particular SSP 585. They wanted to know the worst case, roughly the worst case scenario, so we provided them with the 95th percentile. We always do the statistical analysis when we're doing our work. It's very important to us to have the statistical baseline in terms of the range of uncertainty within the climate models that are out there. We don't just take the 50th percentile and present that. It's actually it's company policy that we provide a statistical analysis of the Earth system models we use so that clients can understand the range of uncertainty depending on the peril that they're accessing. It's a critical deliverable, and it's also very interesting to spatially deliver that sort of thing to our clients, and they get the idea of the worst case or near worst case scenario and what they need to think about and decide how they want to respond to that. Next slide. Same thing with extreme precipitation. We have up to 60 perils that we work with of variables of chronic and acute risks for the retail sector. A lot of it is around heat and extreme rainfall, in particular coastal inundation, which we'll get to in a bit. There's some other issues there that they're very focused on. But extreme precipitation as well is something that we found in Australia recently with Alfred in Southeast Queensland, actually has impact on retailers in that.
Southeast Queensland. There are different scales at which we can look at this as well. In SA2 areas, you can look at wheat yields for historically and also the future in terms of the impact that climate change may have on these wheat yields, for example, here in Australia. We then move on from retailers to flooding and landslide. Here's an example of some high-resolution flood modeling we have done using a 5-meter LiDAR DEM. This is from the January 2023 Auckland floods. What we like to do is when there's a flood event in New Zealand, we like to, where we have an opportunity, record what the flood levels were and then go out and with our modeling, go check our modeling and see if it has captured the flood modeling, the flood event that has occurred. And we did that here in South Auckland from the January floods of 2023. And you see here the baseline flooding levels and then future flooding levels with a 1 in 100 year ARI 100 event using SSP 585 95th percentile for 2050. And you see the new distant flood, future potential flood levels for that. And we have the whole MOTU covered largely at 5-meter resolution with these flood models with various SSPs for the future and different ARIs. Here's an example from Peterborough in the UK, where we've also applied these high-resolution flood modeling with future climate change using ArcGIS to display this. This is about a community modeling project in Peterborough in the UK, where we provided the baseline flood depths and then for a 1 in 100 year event, and then added in future flood risk with an ARI 100 event 2050. You can see there's quite a profound change in the depths of flood across this community in the UK. We also do coastal inundation modeling. This is a case where they're looking at repurposing this land along the coast into residential housing of some sort, and quite exclusive by the sea, but they were very interested in how much reclamation they're going to require to infill this area, obviously, to get it above these potential extreme water levels in the future. This is not just sea level rise, this is sea level rise with extreme still high water levels caused by storm surges, etc. So there's quite a bit of work that's going to need to be done to remediate this site if it's going to be used for housing. Quite expensive, I would have thought, in this particular area and in this particular coastal location. The other thing is landslide. We have worked with various geophysical aspects of the New Zealand environment, looking at slopes, soils, rainfall, etc., working with some GNS data, etc., looking at landslide susceptibility. And like the flooding that I showed previously, we also like to look at extreme events that have occurred. In the case of Dunedin of some months ago, there was quite an extreme rainfall event and some landslides occurred. And one of them was quite prominent in the news, and where it's easy for us to locate where that place was with the aerial photography that had been done. And we checked our susceptibility maps in our landslide database, and it captured that risk quite well, in this case down in Dunedin. The other aspect that we look at for our neighbors in the Pacific, we've been working out in the Pacific and many of the Pacific Islands doing modeling of various types. This was a major piece of work done with the World Bank on drought and food security in the highlands of Papua New Guinea, primarily very much an ENSO-related activity. So we recreated the droughts of 97, 98, very important ENSO year, and also the 2015-2016 drought, which was slightly different. All droughts are different, and this one was characterized a little bit differently. But they also wanted to know about future drought risk in Papua New Guinea. So one example here of taking that 1997-98 drought and thinking about how, if those climatic conditions were replicated with climate change out to 2100, what we might see in terms of a drought analog out in Papua New Guinea in the future. So GIS was critical to that. This was a great case in Vanuatu from nearly 2 years ago now, where we were looking at precipitation as part of a Green Climate Fund proposal that was going to go forward. And they had to make their case for WASH, which is about water supply, potable water supplies for the people of Vanuatu, and the impact of climate change could have on their provision of safe, clean drinking water. So we had to do a lot of detailed climate analysis to present the case for the hazard presented by climate change. And you can see that right away here with the changes in precipitation likely in annual precipitation, which made the case for what ended up being a successful application for the Green Climate Fund for $25 million to support better water infrastructure across Vanuatu. So this is where GIS and good quality climate information was instrumental in helping in the development case in Vanuatu. We also worked with the New Zealand Met Service and the French Embassy out of Wellington on a project in Wallis and Futuna in the Pacific, again looking at dry events and their probability. Drought is a major hazard across the Pacific, and it's not being recognized that well, but it's increasingly an issue, and hence why we did some of this work on drought, among other things, including coastal inundation in Wallis, where again we can integrate satellite imagery with a reasonable digital elevation model, and then sea level rise, extreme still high water levels to look at potential inundation depths around the coast. And this is the case where taro is a major food source in Wallis, and this is often grown in the coastal areas. So this has other implications other than just coastal inundation, also implications for food supply.
Thanks, Peter. Now that we've heard a great overview of climate change, along with some cool examples of how organizations in different sectors are using this data, now let's take a look at how you can get started with your own analysis. I'll show you how user-friendly climate change analysis can be using the tools supported across the ArcGIS system, such as SimClim for ArcGIS, a product developed by ClimSystems. Before jumping into the demo, I'll quickly show you the high-level workflow, just to set the scene and show you the overall process of generating a climate risk index for your assets or areas of interest. There are three main sections in this workflow: the data, analysis, and then visualization. Starting with data on the left, ArcGIS Pro supports various data types, including raster that is typically used to represent climate information. And we will be using SimClim for ArcGIS to generate those climate scenario rasters. Moving into analysis, the goal here is to attach those climate variables to the assets using geoprocessing tools available in Pro. For example, for point features, a simple and effective tool is extract multi-values to points. For lines or polygon features, I recommend using a combination of sample and join fill tools. Once we have an asset with the climate variables, we can then calculate the climate risk index using Calculate Composite Index tool. This helps us combine multiple climate variables into a single score and eventually produce a risk map. Finally, in terms of visualization, the results can be shared through web maps or web apps in ArcGIS Online, making it easy to share with others. Now I'm going to switch gears and show you the actual product. This is how the SimClim for ArcGIS looks like in Pro. It acts like an add-in tool that lets us explore future climate scenarios. This tool is essentially a climate scenario generator. It means we can choose different settings like the area, the year, climate models, etc. And the tool will generate raster layers showing future climate conditions. I'll quickly show you how it works. First, we will need to select our area of interest. In this case, I have the New Zealand data package. Next, we will need to choose the year. This can be either baseline year or future year that we want to project. So for our analysis here, we will be choosing a future year like 2100. Then we decide what kind of output we want. SimClim for ArcGIS can produce two types of results. Projection is a direct forecast of future climate conditions for the chosen year. Change from baseline, on the other hand, shows how much the future climate differs from the baseline period. Instead of showing the climate values outright, it calculates the difference between the future and the baseline. I'm going to choose projection in this case. Next, we get to pick the climate variable we want to analyze. SimClim tool provides 7 climate metrics, and you can choose from any of these. Precipitation, humidity, radiation, different types of temperature, and wind speed. After choosing the variable, the next step is to select a climate model, often referred to as GCMs or global climate models. Each of these models are developed by different research centers, as Peter mentioned before, and each of them may project slightly different outcomes for the same scenarios. So if you're not sure which model to use, don't worry. The tool provides the option to select an ensemble of models, meaning you're taking a bunch of different models and averaging them. Instead of relying on one model's output, you get a consensus from many models. So I will select all models in this case. Next, SimClim also allows you to generate high percentile outputs. This is a way to visualize more extreme outcomes, and it is useful for looking at extreme climate events like very high wind speed. Climate projections aren't just about the climate system itself, but they also depend on human factors like socio-economic development. This is where shared socio-economic pathways, or SSPs, come in. Based on current trend, we're around SSP 3. So for our analysis, I specifically picked that. But of course, you can pick the worst case scenario like SSP 5 if you want to. Another recommendation when using the SimClim tool is to specify the time period accurately. For example, if I want to see seasonal heavy rainfall, I will need to specify that I want seasonal outputs rather than annual averages. Now that we have all the parameters set, we are ready to run the tool. SimClim generates the result as a raster layer consisting of a grid of 1 kilometer resolution cells, and each cell contains a value representing the climate metric. Of course, I have run the tool beforehand, and here I have generated a bunch of different scenarios. We have temperature projection, strong wind projection, percentage changes to seasonal rainfall, etc. The next step is to do our analysis. We need to pull those climate values into our asset data, right? In this case, we'll be using transpower structures. Huge thanks to Transpower for making this data publicly available through open data platforms. To do this, we will be using the extract multi-values 2 points tool. What it does is pretty straightforward. It extracts the cell values at each transpower structure and records those values into the attribute table. So as you can see here, for every transpower structure, we now have not just the asset details, but also the corresponding climate values. Things like projected wind speed, temperature, or rainfall. The next major step is to calculate the climate risk score. To do this, we are using the Calculate Composite Index tool, a method that combines different numeric variables into a single score. Here's how we set it up. Of course, for the input table, we'll be selecting the feature layer that now has both the asset details and climate variables. And then we will select all the climate variables that we want to include in the index calculation. If needed, we can also utilize the reverse direction checkbox when higher values need to be flipped. The default scaling method is minimum maximum, and for most cases you can leave it as is. And furthermore, you can also adjust the weightings if you want certain climate variables to have a stronger influence. For example, here you might give wind and precipitation a higher weight if you think they're bigger risk factors for transpower structures. After setting these parameters, I simply click Run, and this is the output. If I click on the asset, you will see the individual risk index. There we go. Along with a breakdown showing how each variable contributed to the final score. And that's how we calculated the climate risk index for transpower structures using climate data from SimClim. It is important to note that many factors influence the results. Different climate models, variable selections, time period, etc., can all produce different outputs. But with the access to SimClim for ArcGIS and other ArcGIS Pro tools, you can have the flexibility to customize your analysis based on your goals or objectives. But overall, that is the general approach to generating a climate risk index. Now let's take a look at some visualization examples. The analysis of climate risks on transpower structures can be shared to ArcGIS Online. The climate scenarios outputs from SimClim have been published as hosted imagery layers here. And the assets with calculated climate risk index scores can be added to the web map as well. Here I have enhanced the visualization using different symbology techniques such as aggregation or binning method here. Or I can also utilize the new animated symbol to highlight those structures with higher climate risk. And then to share these insights with stakeholders or other teams, web apps are a great option. Here's a simple ArcGIS dashboard that I quickly put together. It is a very useful way to interactively explore the indicators and climate charts. Alternatively, you can also build a more immersive experience using Experience Builder. So this is one of the apps that I showed last year at NZEUC. It is a multi-page climate change explorer app built entirely with Experience Builder's out-of-the-box widgets, no coding required. The first page here lets us explore or compare different climate scenarios generated from SimClim. The second page here displays the climate risk index across New Zealand using various administrative boundaries like territorial authorities or suburbs to identify areas most affected by wet climates or drier climates. The final page focuses more on freshwater system vulnerability, highlighting rivers that are potentially impacted by either increased precipitation or drier conditions. So that was a quick walkthrough of how to calculate the climate risk index in ArcGIS Pro and visualize the results in ArcGIS Online. But if you're interested in more advanced analysis workflows, There are additional methods worth considering, such as weighted overlay or binary overlay techniques. This example is from a project for ArcGIS by one of our graduates, Bianca, who explored different ways to assess climate change impacts in ArcGIS Pro. Her project focused on agricultural suitability around the Waihi catchment in the Bay of Plenty. She used SimClim climate projections with other spatial datasets as well, including slope, elevation, land cover, sea level rise, and more, to identify areas best suited for future agricultural use. So the approach is pretty similar in that it combines multiple criteria to generate a suitability score. However, this analysis relied more heavily on raster-based tools. So that's the video showing how she calculated the suitability score using a raster calculator tool. That concludes our practical demonstration showing how to work with SimClim climate change data across a range of contexts, from infrastructure like transpower structures to freshwater systems, agriculture, and more broader regional assessments across New Zealand. So I'll now go through the next section, resources. I'd like to share some available resources that we highly recommend for working with climate change. First, we recommend ArcGIS blogs and ArcGIS documentation from Esri. These resources provide really detailed insights into how ArcGIS can help your work, offering best practices, product updates, technical tutorials, and other available information for using ArcGIS products. Additionally, you can also use livingatlas.com to access publicly available or authoritative world datasets. We also have an upcoming webinar on the 19th of June. We will have ArcGIS for urban design and planning. Be sure to register if you're interested. And if you have additional questions on climate change, SimClim, or ClimSystems, here are our contacts. Thank you.